Hello and welcome to the VEST webinar series. I'm John Forrester, your moderator for today's webinar session. Today we'll demonstrate how reusable templates created in MDTools can empower sales teams and design engineers to create custom manifold designs. I apologize, my webcam's not working. So you see Megan here. I'll introduce her shortly. This webinar will last approximately 30 minutes, and you'll be able to submit questions or comments at any time during the webinar by just posting in the questions section located within your webinar control panel. Questions may be answered as they are posted, or we'll try to address them in the last 5 minutes of the webinar. Note today's session is being recorded and that the audio is muted for all attendees. If you are experiencing any technical difficulties, please use the chat window to alert our support staff. A link to today's session will be sent out afterwards. Now it's my pleasure to introduce our speaker for today's webinar session, Megan O'Neill. So Megan manages scope and delivery of our VEST 3D cloud product releases, including NetBlock 3D, which I believe she'll be showcasing during today's webinar. So Megan, I'll turn it over to you. Thanks.
Hello, and thank you for coming to today's webinar. So what I'm going to be doing today is I'm going to be demonstrating making a template in MDTools. As compared to NetBlock, MDTools is our desktop product. It is a bit more design heavy, where NetBlock is designed to move quickly and very intuitively for people that may not have previous CAD experience. So the concept of using templates to make designs easier can be used for a variety of schematics, manifolds, and other designs even outside of the hydraulics industry. I'm sure you're all aware. But today what I'm going to be looking at is, so if I'm just using Sun Hydraulics as an example here. So I went on their website, I'm seeing some of this publicly available information, and I'm seeing some of these very basic sandwich body manifolds. So we can look at these, and I'm using them partially for the webinar because they are pretty simple, and I don't think anyone wants to stick around to watch me design a manifold with 400 cavities on it. So all of these include 3 to 4 components, and it'd be normal to look at these types of manifolds and not really see more than 10 components on the block. But for being smaller types of manifolds, we do have some features that it is going to be helpful to use MDTools to create these on. So I'm going to start with this one where we have so some sort of relief valve. It's going to be here, it's going to be here, and it looks like we've got what I'm going to use is a DO3 on the top and on the bottom. But on this bottom face, I can see that I've got some O-rings here. So this is their symbol for using O-rings. So when I'm thinking about how I want to design this, if I add a DO3 on top and I add this one on the bottom, I'm going to want to be able to mirror that footprint down. So that way my bolt holes match up, my locating pin or my dowel pin, whatever you'd like to call it, can match up. And then to minimize the size of the block, I'm going to put these in on the side, and I'm going to have to splay some of these ports to fit the relief valves through the middle. So with that being said, let's get started. I'm going to open Inventor. I'm going to be using MDTools 790 right now because we currently have the mirror footprint command available in 790, where it will be released in 985 soon. So I'd like to show you that, but in a little while. So I'm going to start by creating a block. I've made this manifold a couple times before, so I like to do 3.5 by 3 by 3 inches. I know we usually have Carlo doing the webinars, and he's always in metric, so I thought I'd humor people and do some inches. So I'm going to start by inserting a DO3. And I'm going to make my pressure port red, my tank port blue. And for A, I'll just do net 2, and B, net 3. I'm just going to call this 1. And I'll insert it on the top. And there's our top one. But now things are going to get a little tricky. I'm going to use this mirror footprint. It's under the copy menu. I'm going to mirror the footprint. And here, I'm going to continue to use through bolt holes. But if I wanted to specify drilling from both ends, counterbore, I could here. I'm just going to click drill from both ends. And I can also add the O-rings on this mirrored version right now. So I'm going to select this O-ring. It should give me a little room to angle some of the drill holes. Oh, oops, I just selected the wrong one. There we go. I'm just making them all the same. And depending on your specific design, you may have a variety of different needs. We're just showcasing the ability to make templates to make things easier. Right now, I do have to go to a fresh block. This is how we currently have mirror footprint working in 790. Oh, I should probably enter a component ID. And there we go. So I can see I've got the O-rings on the bottom. I've got these through holes right here. And I'm going to add a DO3 to the top. And let's see, A is net 2, B is net 3, P is red, tank is blue. And we'll call that one 2. I'm just going to do the top face. Insert it here. And I'm just going to do my best to line these bolt holes up with the other bolt holes. That looks pretty close, and I'm going to end up angling these cavities anyways. So. All right, let's see how that looks. Looks good to me. Looks good. So now I'm going to add those relief valves. So for this template, I'm going to use the T162A, which of the sun-related options that I'd find on their website is going to be one of the the cavities for the relief valve that's a little bit smaller in diameter. So I can look at the reference back here. So in the first one, both nets are going to be for this A port, and for the second one, both nets are going to be for this B port. All right, so A we had as net 2, net 2. We'll make this 3, and we can insert it here. Try to get it pretty visually centered. And that looks pretty good to me. Now let's do it again on the other side. This time I'm going to want these nets. I'm going to label it net 4. And I'm going to insert it over here. And there we go. So I have this set up, and as you can imagine, if I used a larger relief valve cavity, so if this diameter became larger, I'd really need to angle this pressure and this tank net out to make sure they didn't hit this cavity, especially because I'm trying to stay in a smaller block. So I'm going to start by angling them slightly, just in case I do want my template users to be able to sub them in and out quickly and to only make minor tweaks as they go. So I'm going to use the stretch command. I'm actually going to look here to do it. And I'm going to select this one, going to allow change. I'm just going to do simple angle holes only, so that means that the inclination is only going to be at increments of 90 degrees. So it's going to look kind of like a compass in northwest, east, south, instead of having these partial angles. And I think 10 will be a good start. And let's see. Oh, other way, we'll do 180. There we go. Right, so I'm gonna get back on this face view, and I'm gonna stretch it about halfway, so at like 0.6. Oop, that was diameter. I don't want to do that. I'm just going to cancel the command and go back. I want this one. Allow change. 10 to 70. And depth, not diameter. We'll do 1.6. And I'm going to say OK. And it is changing the drill diameter a little bit, as you can see up here for the angle hole. This is going to be more of an oval diameter now instead of a circle because it is angled. So I'm going to do the same thing to the bottom cavity. Stretch. This one, allow change, 10. And this one be, yep, that's 90. And let's make it 1.3. How's that gonna look? Oh, let's do a little more, 1.5. Those look like they should intersect pretty well. Okay. So we'll do the same thing to this tank net. Stretch. Yeah, 1.6, 10, and E. Okay. And the bottom one. Oh, 5, 10, 2, 7. All right, so some people call this displaying to allow a larger middle cavity to go in on these smaller manifolds, a bit of a frog leg design to just describe this. So if I end up using frog leg, that's what I'm referring to. But now let's look at connecting our relief valves. So looking back here, it looks like the bottom one goes into port 2 and the top one goes into port 1. So we can use the stretch command for this as well. I'm going to select this. And this time, I'm going to say stretch up to cavity. Pick this cavity, and bottom goes into port 2. But I need to allow for angling. And I'm just going to say simple, so it'll go to 180. And for this, just for even numbers, I'm going to change it to 30. Okay. And I'm going to do the same thing over here. Just allow change to begin with. 2, simple only. And actually, I'm kind of looking at these and these two footprints, and I'm realizing they are not the most centered. So I'm going to use move multiple. There we go. So select this one and this one. Done. And I'm just going to move them just a little bit over here so they're a little more even. So that way this yellow port, I want to drill from both ends. Now I got to align all these bolt holes. I'm going to align with this. Okay. I'm just using the spacebar shortcut to reactivate the command. Okay. All right, so we are back to looking good. And it looks like my angled holes are just still within the good area. So now we'll make those top connections. So stretch to here, but I'm doing port 1 this time. And this looks very, very close. So I'm just going to change it just a little bit. So 180 and just 2. So there I've got looks like I've got a little bit more room. And I'll do it again over here. Okay, so as you can see with those, I do have a connection, but it's not very beautiful. So since I'm in MDTools, I am going to use check bend. So what check bend does is it looks at these connections, and the outcome for this one is it's going to be extending this drill a little bit to make it a little smoother to reduce pressure drop. So we'll start that, and we'll select. So yeah, it wants to extend that drill, it wants to extend this one, and let's say update. So you can see it made those connections a bit smoother. So now that I have this manifold, I'm going to save it as a template. So we're kind of on the A and B axis here. So that means our pressure and our tank are the ones that are frog-legged out. So I'm going to save this as an AB axis template. So I'm going to go to block, export to MVXML, and template, webinar, AB axis, but with through-bolt holes. As you could see in things I had previously saved, I had one save that didn't have through-bolt holes. It's really up to you what variations you are going to need in your variety of templates. So now we're going to get to the fun part where we open NetBlock 3D and we see how someone who may not be as experienced of a user to be using MDTools and to really be messing around with these angle holes, these check bends, adding the O-rings, making the through-bolt holes, how they can easily now manipulate this design to cover a variety of other schematics and make 3D manifolds out of them. So go into NetBlock, ta-da, and now we're going to open that MVXML we just saved. So this is the through-bolt hole one. It's going to load for just a second there. And this should look pretty familiar to all of us. So working with this manifold, I can say, okay, this is the same thing I made in MDTools. I've got my kind of interesting mirrored footprint down there. Oh, shoot. There's a mistake here. I realized in angling some of these and moving them around, I did lose some some O-rings. So I'm just going to add the O-rings back in here. So, nope, it's under here. I wanted to add these 12, so I'm just going to keep adding those. O-ring. There we go. And there we are. And I'm just going to export that again. With the through bolt holes and save. Yep, I'm replacing it. And let's try that again. Okay, so now we have our O-rings. So now this manifold, satisfies what this schematic would like. Now let's say I'm a salesman or I'm a less experienced CAD user, either or. I could be in the room with a customer who says, actually, I want to put a bit of a bigger relief valve on here, or I could be designing behind the scenes and I just get an email that says, hey, what would this look like with a larger relief valve? So some of the other acceptable relief valves would be like if I put a T3A on here, what would that look like? So I'm going to go in my Sun library. So I'm just using our generic library that comes with all the NetBlock subscriptions. And I'm going to say, okay, delete that, add a T3. It's taking a second there. There we go. I go, oh, whoa, that is a lot bigger here. I can say, if I want to do this, I'm going to need a larger block, or I might be looking at one of these instances where I've got the A port and port 1 of this relief valve connects to B and port 2 connects to A. So I'm going to say, hey, customer, if we wanted a 2 relief valve thing here and we wanted T3As, we can't do it on a 3.5 by 3 by 3 inch block anymore. That's a little too small to accommodate the T3A. But if I knew I was working off this schematic and this schematic required a T3A, and there we go. So this one was the B. So I actually want it flipped around. So I'm just going to do some undos real quick here. So just Control Z, undo. And now I'm going to delete that one. I'm going to add my T3A here. And looking at it, now I can see, whoa, I've barely got room for it in my frog legs as I have them sitting now with this tank and this pressure line. So I can pretty easily adjust those if I'd like. I could have also adjusted them around the smaller cavity to make them a little tighter, a little bit less angled. But if I want to adjust the angle, I can just go here and say, this time around, let's do it 15. Let's do it 15 there. And I can also use stretch cavity here to just tighten that up a little bit. And I'll do the same thing over here. And once again, stretch cavity. There we go. And looking at how I have this yellow, the A ports, I'm going to need to adjust that as well. This one doesn't need to be as sharply angled. So let me just turn that down to 5, see what that looks like. That looks pretty good to me. Flip the alpha angle on this one and also put it at 5. So here I'm going to want to change that port 2 to yellow and port 1 to green. I'll also delete this. Delete. I'm going to reverse this as well. And I think I can get away with having that just as 5 as well. Okay, so now look at this and I can say, I keep moving the little toggle for the webinar around because I keep putting it in my own way. So I went from creating this schematic to creating this schematic. Now you can easily see how using that same method, starting with this kind of a template, I could also change my relief valve size here to keep making it bigger, to make it smaller, to if it says that T16A is another sun relief valve that's available, you say, okay, well, what does that look like? Insert it. Well, actually, it also says T18 is available, and that's even bigger. So I could say, well, this just isn't going to work with a sandwich DO3 of this size because of the bolt hole constraints. And I could show somebody that quickly and easily here. But you can see that I could make a lot of these schematics using the kind of that A port and B port access within a minute or two once I have my starting template. So you might say, well, what if I wanted it in these types of schematics where instead of that A port, B port access, it's more pressure and tank. So this one has both port 1 and port 2 going onto pressure. So for that, behind the scenes, I made a similar block, but instead of splaying pressure and tank, it splays A and B and it rotates the footprint. So I'll open that up for that. And pressure tank axis. And there we go. So you can see very similar thing, but just I've got a rotated footprint here. And now this one is connecting this pressure net to the second port and this tank net to the first port. But I looked at this schematic and I said, oh, port 1 and port 2 both connect to the pressure port. Go in here, could add T162. It's just a little smaller, so I know that's going to be slightly easier for me. Put it in there. And if I wanted to, because this is a sun cavity with a locating shoulder, you can even sink the locating shoulder in that block to give myself some other ideas. From here, I'm going to make this angle a little bit more intense. See, I need to go just a bit more to get out of this gray dead area that I don't want to be intersecting. You can see this, it doesn't take a CAD genius to really do this guess and check type of process here. I'm gonna try 10 that way. Looks like it needs a little more, maybe 12. Or maybe I just don't want to sink this locating shoulder quite so much. I can back off of that. So I don't want this red port to intersect this blue port. So if I back off of this, can I get away with 5? Looks like I can. Here, is 25 going to be too much? Nope, looks good. And I could change those both to red. So within the last minute or two, I changed from one schematic to another. If I had a large list of schematics like this, and I don't want to go back into MDTools and constantly be mirroring the footprints, designing, adding the O-rings, making the through bolt holes, making all of these frog leg angles, now I can easily switch them in and out. So we check the chat to see if there's any questions. Don't see any questions so far. Don't see anything in the chat. And yep, and that concludes my portion of the webinar for today. So I'm going to hand it back to John to close things out.
Thanks. We've got a couple minutes left, and great presentation, Megan. So if there are any questions that you can think of, we could still address. Oh, I just saw one pop in.
Here we go. Sorry, I'm struggling to, oh, I missed one thing in the beginning. How did you manage to mirror the footprint in the same manifold? So we can go back over that for just a little bit. So right now, and we are working on this with the MDTools 790 command, as well as what's going to be present in MDTools 985. So to mirror a footprint, you do need a second part. So I actually started in part 2, and we made this so you could attach smaller manifolds to larger manifolds. So we didn't imagine the need for doing it on the same manifold. So, but here it's in this copy menu, or you could search for it up here, do the mirror footprint, select the footprint, and this is gonna look really, really junky because I don't have a lot of room on this block right now, but do whatever type of through bolt holes you want, select O-rings, counterbores. I'm not gonna do this at this time, but, oh yeah, I saying I don't need O-rings. And I'm just going to insert it there. I do have to assign a component ID for it. So that will mirror a footprint. And then if you have your standard footprint that you want to sandwich it with, you can just insert that on top. So it's not going to mirror what's in your library. It's just going to mirror what was in your library for just this one instance, and then you can insert your library thing on top of it. And in that way, you will have these locating pins lining up with the mirror situation. Oh, I had rotated that one and then I inserted it upside down. But yeah, in the first example, you can see the locating pins are mirrored. Are there any other questions? All right, I think that's it.
Yeah, I think the question was answered. Thanks again, Megan, and thank you all for joining again. I just want to let you know that if you have any questions that maybe pop up afterwards, just feel free to email us, and we'll follow up within 24 hours. If you and just email to us at support@bestusa.com with the details, and we'll get right back with you. Again, I'd like to thank Megan for delivering today's topical webinar. And we'd be grateful if you could complete a short survey at the conclusion of today's webinar. It'll pop up on your screen. Tomorrow you'll receive an email containing a link to view a replay of today's session, and feel free to share that link with your colleagues as well. A link to new video segments from prior webinars will also be provided in that email. As you can see, we have the webinar series posted on various social media channels, and we invite you to follow those channels so you can get the very latest updates on upcoming webinars, as well as product releases. Our next webinar takes place in 2 weeks, where the efficient design of compact manifold blocks accommodating filters will be demonstrated using MDTools. So feel free to register for that. And we want to again thank Megan and thank you all for today's session. And we wish you a pleasant and safe day. Take care.